Hello, and thank you so much for having me today here to give the presentation about the Master Rubric for Bioinformatics. My name is Jessica Lindvall, and I am from Elixir, Sweden. And in Sweden, the Swedish node consists of a research infrastructure called National Bioinformatics Infrastructure Sweden, or NBIS for short. And today's talk have the title of Introducing the Master Rubric for Bioinformatics, Applications to Training and Professional Development. However, this is not a one-man job, not at all. It has been a team's work over several years. Some of the team members are most probably in the audience here today, listening to this and can answer questions when they come in into the chat and also afterwards. And these are the people I really want to acknowledge: Rochelle Trachtenberg, Allegra Via, and Terry Atwood. And since this is a recording, I ask you to place the questions in the chat, and team members will answer them or save them to after the presentation, where I hope that this presentation will spark some thoughts, ideas, and discussions. So here we go. The overview of this presentation is that I'm thinking that I should give you an overview of what the Mastery Rubric for Bioinformatics is. I will continue with a visual tour, which basically will be the same as in the first section of the talk, however, in a bit different, slight different way, which we hope that will help you digest the Mastery Rubric for Bioinformatics further and maybe put it in other perspectives. And in the end, I will show you two ways how to use the Mastery Rubric for Bioinformatics and how this tool can really be a support and help to you when you either set up a course or in your own professional development. So what is the Mastery Rubric for Bioinformatics? You can find all the details of the tools in the paper that we published in late 2019 in PLOS ONE, and the paper is called The Mastery Rubric for Bioinformatics, a tool to support design and evaluation of career-spanning education and training. And you find the DOI at the bottom of this page, but please, you don't need to write anything. The presentation will be available to you later on, and also the reference will be gathered in a slide at the end. So for those of you that have read this paper, you have already discovered Table 1. And Table 1 in the paper is the Mastery Rubric for Bioinformatics. And essentially it is a descriptive table with 3 dimensions, where you have the y-axis that lists the knowledge, skills, abilities, the so-called KSAs, and these are the intended KSAs that should be delivered by a course or a program. And then you have the x-axis, that outlines a developmental trajectory from less to more expert. Here it is from novice to independent journeyman. And then you have in the individual cells, like the one highlighted here, that describes in detail how a learner might be expected to perform, and then how it changes over time when then progressing along that trajectory, so along the x-axis. And these are the so-called performance levels descriptors that you see in the cells, the so-called PLDs. And as you can see at just this first glance, there's quite a lot to take in. So to help navigate a bit through this table, or to better orientate ourselves, I can say, we can highlight its main features. And this is exactly the same thing, the same slide, but just colored in. And here then at the top, you have the general description, and it's a general description of an individual at a given stage. And I should say that you're not meant to read this. It's just for you to note that there is a progression as an individual advances from novice to journeyman. And alongside this description are the requisite stages of Bloom's hierarchy of cognitive complexity. And this builds from lower to higher order critical thinking skills. So from Bloom's level 1 to Bloom's level 6. And then beneath these are the 12 KSAs and their corresponding PLDs for each stage. And however, this is just the first page of the table, and as you can see, it is massive. And it covers a total of 6 pages. And clearly, I mean this really also for myself, this isn't the easiest thing to digest. So let's see if we can summarize the whole thing in a much simpler table. And this can look like this. So again, note the 12 KSAs on the y-axis, one on each row. And I should point out that these KSAs are not to be confused with the KSAs encapsulated in various competency frameworks that are out there. So these KSAs that are referred to here in the Mastery Rubric are much broader and or higher level concepts, one can say. And then, as before, the stages are along the x-axis and denoting in each column a particular point in the developmental trajectory, from less to more expert. And then the descriptions of the learner performance, the performance levels descriptor at those levels that are given in each cells. So the key take-home message here is that the KSAs, the stages, and the PLDs. This is the Mastery Rubric for Bioinformatics. And it is a big ask to expect anyone to take all of this in one go. So let's try now to look at the Mastery Rubric for Bioinformatics from a slightly different perspective. And this is what I meant in the beginning of the talk. So hopefully this will help you to mentally unpack its components and also to better show how all fits together and how it can be used. And it's important to stress that the key thing here is the concepts and not the details. So try to keep that in mind. And again, if you have any question, paste them in the chat and someone from the team will answer them, hopefully. So the first thing to note is that the Mastery Rubric builds on the European Guild structure. And the European Guild structure outlines a trajectory from apprentice through journeyman to what was originally called master craftsman or tradesman. And this European Guild structure is ancient, so this has been around for centuries. However, the Mastery Rubric adds 2 further stages, that is novice and beginner. And the Mastery Rubric also differentiates the journeyman stage into an early and a late stage, so J1 and J2. And this is to recognize that the journeyman period is generally the longest phase of training. So what I mean is that for instance, it's observable differences between a newly qualified individual, say a new PhD, and then one, say, with 10 or more years of experience. And that could be an independent research fellow or a PI. And these two, and the later one, has arguably achieved master in his or her subject. Each of these stages can be mapped to the relevant Bloom level. From remember, understand, which is the lower level B1, B2, through apply, analyze, B3, B4, to synthesize and evaluate, which is B5 and B6. And then similarly, each stage can be mapped to stages in what we see as traditional academic trajectory, from undergraduate through masters to PhD to postdoc fellows and ultimately to an independent PI. And as shown earlier, the Mastery Rubric lists the KSAs a program is intended to deliver. And for bioinformatics, these are based on foundational discipline-specific KSAs. And here we have prerequisite of biology and prerequisite of computational methods. Then we have 9 further KSAs that are based on scientific method. These are more domain unspecific KSAs, so independent of your domain of expertise, these are KSAs that should be following your trajectory. And then last but not, we have the ethical practice. And hopefully this is the beginning to give you a better feel on how each of the stages builds layer upon layer onto the next in terms of cognitive complexity, so advancing in blooms. And this is as an individual progresses from less to more expert, so from novice, which is the outside layer, to independent scientist, which is the inside layer. So let's take a closer look at this layer by layer. Hidden within each of the layers are the performance level descriptors, the PLDs, that describe what it should look like as learners develop from less to more expert, and then demonstration for each of these KSAs. Again, you are not meant to read this. And as we saw before, alongside the PLDs are a general description of an individual at this stage. And then you have the requisite bloom level and the stage of academic training. So here, for example, the novice is somebody who reads and generally understands, but doesn't question research results, etc. And the Bloom's level would then be remember, understand, 1 or 2, and that reflect this statement of description. And this could typically describe an early undergraduate thinking. And at this stage, beginner stage, this beginner is beginning to learn how to apply software to a given problem, etc. And the Bloom's level have changed now accordingly, as you see, to understand apply, which is B2, B3. And this might be a typical description of an early master student. At the next level, the apprentice, this is someone that's becoming more expert at analysis, but may not be aware of other equally viable approaches, hence still need guidance. The Bloom's level have progressed from applying, analyzing, and beginning to synthesize. So we are talking here about B3 to early B5 in the Bloom's hierarchy, and which might be a typical description of late masters and early PhD students. At the first journeyman level, the J1, here we find a newly qualified independent scientist, but in fact, general still requires some supervision. This is typically of an early postdoc fellow, for instance. And the Bloom's level has moved on to include the ability of such individuals to evaluate, but with guidance still. At the second journeyman level, J2, here we find the confident expert in his or her field, most likely a PI with an independent research group. And this individual has the cognitive abilities that are of the highest Bloom's level, that is of evaluate and B6. And now then, bringing all of these components together, these cognitive layers, this is the Mastery Rubric for bioinformatics, a standard framework for developing scientific and discipline-specific KSAs, from less to more expert. And one of the really useful things about it is that its structures readily allows it to be adapted to related discipline. And this is just simply by changing the discipline-specific KSAs, while keeping the scientific method related KSAs essentially being the same or intact. So it's a plug and play tool, if you like, for related scientific disciplines, as then for the bioinformatics field, the prerequisite of biology and the prerequisite of computational methods are the domain-specific cases. So now when I have presented the tool, how it looks like, and hopefully at least started to unravel the thing for you, how can we then use it? Because a tool is just as good as how you use it, right? It's not really worth a lot if you can't use it. That goes for any tool or program that we do. So how do we do this? We will first take a look at a simple application to professional development. And this is intended as a brief run-through, again, to illustrate the principles rather than the details. So keep that in mind. In this application, we imagine that a life science PI wants to become self-sufficient in basic bioinformatics techniques and not have to hassle his or her colleagues or students for help. And this individual recognizes him or herself as a J2 independent life scientist. And this is someone who makes predictions, evaluates relevant methods, and can generalize to other biological systems, and so on. And as you can see in the highlighted performance levels descriptor here, and note that the requisite Bloom's level reflecting that. So this is a person that is a J2, evaluates in the level of Bloom's in the biology KSA. But this individual also recognizes him or herself as a beginner in computational methods who wants to understand how to code and apply bioinformatics tools in his or her work. Again, note the change in Bloom's level here, please. And who consider him or herself as a J1 in identifying relevant data, but needs help to identify relevant bioinformatics data resources and to evaluate their relative strengths and weaknesses. Who recognizes him or herself as a beginner in identifying or using appropriate bioinformatic methods and interpreting results, needing help to apply specific bioinformatic methods and to understand pipelines and to fully understand stated p-values in program outputs. Again, the Bloom's level reflect all of these things. Who recognizes him or herself as an apprentice in drawing conclusions and ethical practice, and needing help to contextualize and synthesize coherent bioinformatics conclusions and to apply bioinformatics relevant ethical practices, and so on. And although here it's just cherry-picked some indicative phrases from the relevant performance level descriptors for each stage of each KSA, and just for illustrative purposes, I still argue that the PLDs should not be taken entirely literally. The PLDs are intended as guides to the types of behavior learners may exhibit at a given stage of a given KSA, but other description could be more relevant or suitable, depending on the context and/or type of course being offered. So that is quite important to reflect on here. Overall, in this way, the Mastery Rubric for Bioinformatics can be a useful tool for self-guidance, helping individuals to pinpoint and focus on their specific training needs. And if shared with an instructor, these provide key insights about those training needs to the instructor. A key point here is that J2 in one discipline may be, and almost certainly is, a novice, beginner, apprentice in some other discipline. Every individual's background is different. And as an aside, this has important ramifications for students in your classes, which may include complete novices, new to an undergraduate program, and mature students who may already have a master's or PhD. They may be apprentice or J1 in another, perhaps related discipline. And again, everyone is different, as we know. Then coming to application 2, very briefly will be course design. Again, it's the principles and not the details that are important. In this application, we imagine being a university teacher who wants to develop an introductory module for basic bioinformatics master science course. The first step is to identify the KSAs relevant to the course and appropriate developmental stages. So let's say that we want the module to build from foundational, beginner level biology, computational methods, and ethical practice. To apprentice level, applying appropriate methods, interpreting results, drawing conclusions, and communicating. So putting these layers together, the focus of this module is on building up from beginner level biology, computational methods, and ethical practice to apprentice level identifying and using appropriate method, interpreting results, drawing conclusions, and communicating. So we focus on these stages and these KSAs and we ignore the rest. To build a course around these, indeed any course, of course, focusing on any KSAs, so we recommend following a structured paradigm to build a course. And you can find more details of our recommendations in the guidelines for curriculum and course development. And this we made as available as a preprint in the SOS archives last year. And we also released a more practical hands-on version specifically for trainers. And you can find that in this F1000 Bioinformatics Education and Training collection. And again, do not need to write all the DOIs and references. It will all be part of the presentation and shown at the later slide. And in these documents here, you will see that we use something that is called Nichols five-phase paradigm for curriculum and course design as an exemplar, which is illustrated here in the diagram on the left. And details of the model aren't important here. So the point is that there are 5 key phases in the course design process, from defining LOs to selecting LEs, so learning experiences, to selecting content, devising appropriate assessments to course and evaluation. And at each phase, there are a decision point to test whether specific criteria have been met. For instance, are the learning objectives SMART? If the criteria has not been met, either the phase requires revision, the previous phase needs revision, or phase 1 needs revision. And only after this iterative cycle of revision and refinement at each step can the process be regarded as complete. Then coming to the gold star. And the crucial take home here is that phase 1 is the first class citizen of the design process because each phase must be congruent with it. And phase 1 is articulating the learning outcomes. So everything stems for articulating good learning outcomes, smart learning outcomes. So we start the course design process by articulating the intended learning outcomes. And these are statements that detail what students will be able to do and the teacher will be able to assess by the end of a course. So learning outcomes are phrased actively. articulating what students will be able to do. For instance, by the end of this course, students will be able to, and then for this course and module, appropriate beginner level, understand, apply, and learning outcomes for biology might then be, by the end of this course, students will be able to explain the central dogma or describe the challenges of gene prediction in terms of gene structure. And for computational methods, appropriate beginner levels, LOs, might be, by the end of this course, students will be able to list popular databases and protein sequence and structure analysis tools, or search databases using BLAST or other bespoke software tools. Appropriate apprentice level, apply, analyze, and synthesis LOs for identify and use appropriate methods might be that by the end of the course, students will be able to apply fingerprints and apply fingerprint and HMM tools to identify the family to which protein sequences belong, or for interpretation and of results. By the end of the course, students will be able to analyze search outputs to determine the biological significance of results. And for draw conclusions, by the end of the course, students will be able to synthesize results from different analyses to draw preliminary conclusion about the likely function of protein sequences. And then for communication, by the end of the course, the students will be able to present results to a lay audience. And note that these are all active behaviors at the requisite Bloom's level that the teacher will, in principle, be able to assess. And the examples are clearly just fabricated, but hopefully will show how learning outcomes can be informed by the relevant KSA and PLDs at each stage. Again, the performance level descriptors are not meant to be taken literally, but rather to be used as guides towards what might be appropriate behaviors and outcomes at a given developmental stage. And that is really it regarding the tool. And personally, I find this tool used in this way really helpful, both with regards to my own professional development, but also with regards to designing courses and modules or sessions of any kind, actually, just by looking at the Mastery Rubric for Bioinformatics as a tool in this more visualized way helped me to choose the right, to state the more correct and actively learning outcomes that are smart. So I hope that you also will find this tool quite useful in both of these senses, and maybe also find other use cases or ways to use these tools. So just as to conclude, the Mastery Rubric provides a standard framework for developing scientific and discipline-specific KSAs, from less to more expert. The Mastery Rubric for Bioinformatics the structure allows it to be adapted to related disciplines simply by changing its discipline-specific KSAs. So the Mastery Rubric structure in itself allows you to build another Mastery Rubric for another related discipline. And it's a multi-layer tool with applications in professional development and course design. And with that, I just like to say that it's not as scary as it looks. So why not just try it? See how it feels and let us know how it works for you. And with that, thank you so much for your attention. Here are the references that has been written throughout the presentation. Again, here is the team with all the contact information if you at any point want to get in contact with us. And I'm sure that some team members are in the audience, even if I'm not there, that can answer questions that have been rising up during the presentation, or any discussion would be so nice to have. So please reach out, and we can have a Zoom fika, a Zoom coffee at any time and discuss more. And thank you so much and have a really lovely conference and meeting. Thank you.